Yeah, you got to be a bit of a masochist, just a little bit. Gray still plays. You have to be. It's almost a requirement of this kind of game. But I thought I would do a couple of notes on this one, seeing I didn't last night. I wanted to just let some of it temper off, or sometimes I like to play it hot. It just kind of depends. This thing is something you've seen from my work before. I got a lot of geometries where I did it, but for this time I thought a neat way to apply it was straight down the barrel for a chip design. Now, remember, unit measured is going to have a lot to do with molar mass, physics, and so on and so forth, but specifically I repressed it. I wanted it to go down -1. I wanted it to decay, right? Because I wanted to apply a decay state properly through charges, that it is a decay into 1, because elements are going to increase their shell out to 7, right? So when they decay like that from hydrogen down to osmodium, or Og, Mavellodium, which is like you take calcium in a hadron collider and you have plutonium, I think is what it is, and you collide them together out of a series of number of probabilities. There's going to be a half-life created, or a stable element of I think it's Mavellodium out there off of the name. Now, before I get into some dark star over here about what type of salting it received before, because there are some states where I could argue, which one do I want? I wanted, oh yeah, this guy right here. It's a neat way to look at where it's positioned, how it would have Einsteinium, Kentuckium, and everything else in it. But that's not what I want to focus on. That's more of a doping problem of amounts and proportions and figuring out the ultraviolet of it, about why Big Bang information is what it is. Now, that's pretty fancy on the end of things. But technically what I'm doing is I rectified this, right? I'm saying on these charges, there's going to be a diode here, a diode here, a diode here, and a diode here. And inside of that chip configuration, that's essentially what all that right there is. It's saying that this diode and its bit 1/2 is relative, so that way it's going to skitter out. And I want that to skitter out in such a way that it understands its geometry. Much like the supersymmetry, when you get down to just the copper wire, that there's an end of it where the charge is going to want to go, equally like from its midpoint in the coronal aspects of energy out of the solar system. It's either friction and air molecules that reduce a charge with it's a Van de Graaff machine thing. It wants the conductivity of its components is more conductive or less conductive relative to what coronal radiation zone you have, or a coronal zone on our star, where they're in an AP type star, you'd have a radiation zone where it's dominated by radiation, not magnetism and convection currents. So in that logic, I wanted something to say, I know that this isn't the EEPROM. I know that this isn't the exact geometry of something that applies to those types of rules, but it's important to understand the geometry, because I want it to be able to circuit correctly and equally transmit through what it needs to do. And you could do that with a number letter-based system that determines how it does that. Now, again, I didn't use numbers here. I very easily could. I'm starting to use that sequence. Is it relative, potentially, that this has to stay in some metrics? Well, I don't have the supercomputing necessary to follow the logic to apply it into that 3 base, right? I got A, B, and C, and A in a lowercase standard for it. So right there I have 52 letters, 52 characters. 52 characters with a potential another set of them gives me 75, but I'll need 81 characters to be able to fill this in there. So what are those characters? I don't know. Why do they combine? Where does A1 start to kick into this, that there would be a decay state to why mathematically this geometry with symmetry wants it to do things Z, X, Y. Z, and it's going to be somewhere up in here. And in this case, I said because of symmetry, like that wire up top, that you could individually have a type of chip structure where this one, instead of wanting to be here, I'm going to say that I'm going to scale that geometry up a little bit because it's going to square law, not necessarily the power of square, but how that would communicate to why I needed to give myself more space to do some computing inside of there with the physical geometry about how it's going to conduct and cycle through there using the loops that it's going to need to do while conducting what energy is going to want to do: heat, light, and sound. And when it can't do that, it's going to do energy and some kind of whole current or imp current with that, right? So how do you define what it does, when it does it? By defining the geometry and being efficient to why it's not going to spend extra time running loops through here, because those loops would create friction. That friction could create heat. That heat is in some way this triple point on the scales of adjustment that you need to do. And so the only way to really to perceivably get underneath something like that is to have a better geometry. I'm not going to say it's going to zero it down to Kelvin, but you could see with the proper transition and being able to split into certain places to distribute that or ground it out while utilizing that ground energy. An ice bath, for example, is a zeroed out ground energy where I'm applying gravitational forces to help me conduct the experiment. Now, technically, whatever emulsions inside of the beaker that's in the ice bath is going to range unless I have a condensing column or a water-cooled pump, Nile Red doing it. But technically, both of those are zeroed-out systems. They will both conduct that aspect. It's not as controlled. You might have some emulsions pop off in that because it's not a perfectly controlled. As I add phenopene, what is it? Yeah, well, whatever it is, it'll add an exothermic or endothermic to the not entropic, the anthropic, which means that I have to maintain cold to push that reaction up there. If that cold doesn't happen, then the pH level doesn't do what it needs to do. And so that's always happening. That's always happening in some way in physics, even if you're not physically perceiving it. And when you don't perceive that, you might have a dark matter calculation or something like it'll oxidize. That's why you need zinc anodes or zinc sacrificial anodes on bridges. Now, you're not looking at it overall, but as long as that decay is actually happening on those zinc anodes, that does reduce the bridge. Now, I can't necessarily say I believe it like I've seen the schematics. Here's a bridge without a zinc anode. Here's a bridge with a zinc anode. They're right next to each other with the same components and everything else. And that is for true the math. But it's reasonable that the science makes out with that. Why keep adding zinc anodes to these things for a zinc scam down the line on the thing? Doesn't make much sense. And you'd have a lot of friction about that because of the pipe works. So that's kind of what I'm talking about with this square. I'm making that point jump through all of this and then distribute itself consistently. Now, I don't know what scale of power that would come to, but it would also work this way still. Even if this was a 369 by 9, 10 to the 10 to the 10th or whatever the heck it is, it would still correlate through one of these corners. Now, it doesn't matter which way that goes because it's going to be that sacred geometry, right? It wouldn't matter. It's going to skitter out in one of those two directions. It is relative. When we look at the solar spots on those stars up there, you'll see in some of those other diagrams, the magnetism one where it flips its poles. It's more of a new one about the, well, not Tabby star, but the way that the star comes across, and we've dropped into a solar maximum, a solar minimum. We had the little ice age. What causes those numerological differences? And when it comes to those charts, as far as mathematicians and scientists here, it didn't come out like this butterfly pattern on those things. First, somebody was observing the top side of the star. Then somebody was observing they were always observing the whole star. There might be a pattern, and then as the solar maximum drops, it'll come over into the middle band, and then that lower one, the southern pole, unless the poles were flipped that season, with the aspect of that 11-year solar cycle, would it correlate to that? Now, again, this is what you would ask. This is what you'd be asking this chip to produce for you. Is it relative? Do I need just this singular form because the processing bits here are, what do you say, 9 times 81, right? And at this level, it is 81 times 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 cubed, I think is what that correlates to. And I'm not exactly sure how the mathematicians would put that, but I know for sure it would skitter this. It would want to run some sequence. It wants to run this way, it wants to run this way, it wants to run this way by the lowest energy state, by changing orders this way. Not to say that it couldn't geodesically jump some states at times, given prime and the way that works, but you would need some level of computing at that level to do this. Kind of like that star up there that they were salting, that you could argue was salted or something like that. That you have to be able to start with a heavier element to get that kind of abundancy of Kentuckium or Einsteinium. Now, regardless of the fact that Einsteinium and Kentuckium is man-made elements, did anybody here ever think to themselves what the mathematical molar mass differential would have been to say why that unit measured correlates to something like Einsteinium? Or maybe that differential to say that, yes, it's potentially stable, and that's why that number differential is offset to what that clean mathematics would correlate into a general field theory that requires more of a AC-DC type of demonstration of what electricity really is. So what that correlates to is that just because you find something in a star like that doesn't mean that with the heavier elements added into that, in that radiosphere or the radioactive coronal sphere that's created in an AP type star, comparatively to your standard A type star or S type star, R star, lower. That you could get an abundancy of materials like that, even though that they are considered man-made. They are man-made in an environment of weak gravity where we're still talking about 1 and 2 is the differential of something the size and scope of the coronal sphere of a star. It's pretty intense when you think about a number differential like primes and how they work. Can't really multiply 0 or divide by 0, but that's essentially what's happening at the approximation between those states. And even though this doesn't look like it's a computer, essentially it's Turing complete. As long as that drunkard walk problem starts going, then I could use that as a described model in time and space to say whatever shift matrix you're working. That's why the simulation correlates to the same way in a different field in general. Yeah, a lot going on in there. I'm not exactly good with the chip design, so I can't really help you. But I know it's skittering on something like that. I know it wants to start into there. And I know it has this pyramid aspect for whatever reason. It wants to like kind of build in a fusion state. Or, a fission or a fusion state here. Because it's getting a bit of both. As these fission from each other and divide, they're also fusing at the same time. So more of a Euclid or a Euclidean space, a house of leaves, a Laminar space. It's smooth, but because of that smoothness in an eddy current, this friction or this weakly attracted gravity is created, which defines why its position would want to be there relativistically, because it's still throwing through this. Now, when those other combinations come in, they have to all link into that proper superposition so that way they can jump. It can't be just magic, that's for sure.